Once we obtained the satisfactory result on this preview render, obtained with low resolution 800 by 580 inside V-Ray, we have to work on the various settings to enhance, to increase the quality of our render. So I open the V-Ray render settings and we can start to discuss about them. The first real settings that we notice the crappy quality is the anti-aliasing. As you see, every single pixel is defined with a color and there are no transition between one pixel to another. Now, because the resolution is very low, the benefit of the anti-aliasing is limited on the amount of pixels that we can use. By the way, you will understand soon what I mean. So I open the V-Ray panel, and here, where there is the type of the anti-aliasing, we can use fixed, adaptive subdivision, and the new progressive path tracing method. Actually, I'm using the old school method of V-Ray, and I appreciate really a lot the fixed method. There are methods that speed up the process, like the adaptive or the adaptive subdivision, but when you have many detail, many shading, many different parts, you can have a good benefit in quality from the fixed. The fixed actually offers the maximum quality that you can expect. The negative aspect is the render time that actually is quite long. But here you can save a little bit of time with other methods like the adaptive or adaptive subdivision, while fixed gives the maximum result here on the carpet, the book, the sofa, and so on. Fixed is also very predictable on how it works because it's subdividing each pixel 1 time or 2 times, 3 times, 4 times. Remember that this subdivision is exponential because V-Ray is progressively increasing the resolution of the render. So for 1, he checks the various pixel color. For 2, he's doubling the resolution, so he's doing the subsampling in the various pixels to check what is behind each single pixel and if there are colors that can be blended together. 3 is 3 times your resolution, 4 is 4 times, and so on. Generally, proper values are between 5 or 7, but with such a value, you can expect a huge, very long render time. Let me show you with this region, how is the render time with the various settings that I'm using. And we got this render in 5 seconds. Now, if I increase this to 4, that is a quite good value, and I render again, the render took longer, 7 seconds, not so much, but it took longer. You can see that the various elements are smoother. Now, I have a very low resolution render, and I'm in this close-up, but you can see at 200% how this part of the image is smoother. You can't exaggerate with this value, but still you can notice good benefit also in the shading of your object, because check here behind the shading of the sofa. Let me take a good area like this one, and if I render with the values of 4, I can have a very cool benefit here. You see that also the shading got improved and the pixels are better defined. Now, you may notice that we have this grainy effect over the element. The grain is difficult to be removed from the various settings of the renderer, but the best point is to understand what is creating this graining. Actually, I can tell you, because if we open the material editor for the sofa, we can search the reflection amount, and you see that the sofa is not reflective and not refractive. So it means this grain is not created by the reflection and refraction like they usually do, because generally grain is created by these secondary bounces of the rays of the view. When your material is not reflective and not refractive, but you can see this grain, is because the grain is created by the light emitter. How? Is created using a rule, and the rule is the wider is the light, the more samples, subdivision, you need to subdivide the shadow to obtain a proper result. So here I have 8. Let me show you with 32, assuming that this is the light creating this problem. And as you can see, I got rid of that annoying grainy. A little bit remained, but probably is because the sofa is also affected by this light. So let me apply 32 also here. And while I'm working on the light, I apply also 32 on the last light, so I will not forget about the wide light panel subdivision. Every time you increase the subdivision, obviously you can expect longer render time, but check here how smooth is now my render. Sometimes you can have the same problem in a reflective object like this one. So let's see if here we have a problem of this grainy and noise. It's very difficult to notice here because we have this dark material, and actually it's not convincing me so much now that I'm watching it. But maybe we got rid of that amount of grainy effect. So the anti-aliasing supported us and the subdivision helped us even more. But some grain here remained. It's very difficult to notice, so it's for advanced user, but you can see that there is a grain remaining. This grain is the one I was telling you before, and is created by the reflective or sometimes refractive material. So because this object required to be subdivided to obtain here the reflection, the glossy reflection, the subdivision amount is 8. When you decrease this number, you have to increase the subdivision number. So let me use 16 here. So it's more than the double. Actually, the number is double, but the result and the value that is being used is much higher. So it's not solved so much, but the render time increased. This is, by the way, the first step that you need to use to clean these values. Now, the other problem is the lack of pixel that V-Ray can use, is the lack of information that V-Ray can use to understand what is happening in this situation. So if we don't have so many pixels, we need to increase the resolution. Let me move to the 5000 pixel resolution. It's not so big resolution, but still is not crappy like 800 by 600 that actually is half megapixel. So let's check here, small render, then I draw my region here, I stop the render and I activate it again. So now it's rendering just this part. And you can see how long it became the render process now. But the quality is absolutely impressive. It's very clean. Here we still have a little bit of noise, but the quality is very good. So I interrupt it here and I decrease this number because it's too much. Maybe you can use something like 8, 10, 12. Don't exaggerate with this number. I saw user using 25, 30, but they are for very low parameter of glossiness. Otherwise the render time it will be too long. So what else we can do to improve our quality of the scene as well as the light? So let's check in this area if something weird is happening. And actually nothing weird is happening here. But the number that I used for the light that gives me this grainy for the white light, this 32, is too much. So I can decrease it to 16. And let's see if the render can speed up. And yes, we have a faster render. But still we have some detail and some disturbance here. So the next step is connected on how the light is bouncing inside my scene. I can open the GI where at the beginning I told you to trust me in the Irradiance map and light cache usage, and I can show you what is happening. The light cache is the first passage that the engine is doing on the secondary bounces. So the light enters and arrives from one direction, bounce on one object, and there we have the primary engine calculating the energy left on that bounce. And then the light will continuously bounce inside the room. So all the other are secondary bouncing. So remember, first primary bounce and then secondary bounces inside the room. Primary engine, Irradiance map, secondary engine, light cache. I start from light cache because it's the first one that we see. So if I increase this value, V-Ray is calculating many points for my light cache. You can see this amount of points that are getting improved and improved for the render. The more they are, the better will be the render, but of course the render time is quite long. Light cache is very important for these secondary rays, and I suggest to use a value that is not more than 1000, depending on the distance of the object that you are looking and many aspects, but generally for still render I suggest not to go over 1000 because I'm saving time. I want to use something like 750. The Irradiance map is very important for the bounces of the light of the primary. Should be used in advanced or in expert mode. Advanced is quite enough. And I can show you with this, instead of full preview, let's use show new sample as green. Look what is happening here. You will notice that V-Ray will trace a series of green dots inside my space. So this is the light cache, and is dependent on the amount of pixels you have in your image, I mean the resolution of your picture. And he is progressively trying to understand with a certain pattern what is happening behind the various pixels according to the energy, the amount of light. After this process, we'll have the primary bounces. There it is here. So this is the first pass, pass 1 and 2. And now you may notice the second pass starting here. So I can interrupt it. And we can have this green dot. So V-Ray obtained 1/4 of the resolution of the render and checked how the light is behaving. Then he moved to 1/3 of resolution and checked again and made a comparison between one render and the other. Still, they are not final render, but he tried to understand how the light is behaving. So if I save this Irradiance map just to show you how it works, I can have here a temp Irradiance map. I don't care about it because it's not so important for other things that I need to do. But if I go inside V-Ray Advanced and I check inside the tools, I have this Irradiance map viewer. That is quite cool to understand how our Irradiance is behaving. Irradiance map is asking me for a file, so I take this one, and here is what we have. This is the scene as it is analyzed by V-Ray to understand the various intensity of the light. And some area are not fine-tuned. You see, some area they still have the big light, while other areas they have this small light dot, because V-Ray here was able to understand how the light is working. So you can understand that the smaller are the dot, the better is the result. But the smaller are the dot, it means that V-Ray required to pass multiple times. I can show you with custom what is happening. So let me reduce the light cache because it's consuming too much time. But if I make here a rectangle in this area, for example, and I render with -10 and -9, V-Ray will render 1/10 and 1/9 of the resolution to understand how the light is behaving. And that's it. This result is very approximated and is very low quality. So the light will be very smooth, but very approximated, very interpolated, let me say. This is the right word. While if I use -10 and 0, look now what happens here. You will notice that V-Ray will pass here 10 times, and progressively he's increasing the resolution, so the green dot, they will be smaller and smaller. And every time V-Ray is increasing the resolution, is finding new point, some missing point from the previous render. So here there was nothing, and also here there was nothing new. But on the border here, according to the edges of the object, yep, we have new element. New point that required to be traced to preserve and to guarantee the high quality of our visualization. The result will be very heavy, quite long, but very detailed on how the light is behaving between one point to another. Now, instead of doing the render, I can save this file. And check this out. You see how this area is detailed? We have many points capable to define the light. So this is the theoretical things that happen also there, you see. This is the theoretical thing that happens. Which is the suggestion? Well, the suggestion is to have enough point, so I don't have a precise number for you, but is to have enough point to describe the various surfaces and the various detail. So your render should be balanced between the flat areas and the detailed area, and the subdivision as well as the interpolation should be a higher number. So between one point to another, V-Ray is calculating other number. You can try here with the preset. So very low is 1/4, 1/3, while high is 1/3, 0. Here, generally, I use something like -4 and 0, or -4 and -1, if you want to be sure that you are preserving. And as subdivision, I can use 30 and 25 when I notice some cloudy effect here around the image. So this will work on the indirect light irradiance map. Then I have my light cache, and I can use 700. And for what may concern the filter, I use this length sots filter. It is a filter on the texture and on the final image. It's similar to the fixed, but it's not the same, because the fixed is how the pixels are counted, while this defines how the color between pixels is managed. And I have subdivision as 4. I'm quite happy. Maybe I can reduce even more these lights, because they are quite long to be calculated. And last passage is here, the global DMC, that is actually the heart of V-Ray, on how all the parameters are matched together, and the smaller is the number, the better will be your render, because these numbers here, they define the amount of quality where V-Ray has to stop. So when V-Ray is rendering inside one square, he's calculating the quality of each single pixel, and when the difference between one computation and the next computation is under a certain threshold, then that area is considered clean and V-Ray moves to another series of pixels. So very quickly, these are the tricks used to define the render quality.